Hi everyone, and welcome joining us for the AWS 101. Thank you all for joining us. Um, Short introduction. My name is Josh. I'm the managing director of Devops Pro here in the UK. We're a company that does DevOps consultations. We do trainings, some implementation depending on the client, and we have experience over 10 years. And we love what we do, and we try to bring up the best solutions for all our clients. Uh, Throughout the webinar, if you have any questions, feel free to send a message, anything that you come up with. This is going to be the beginning of the road with AWS. I'm going to be covering the basics of AWS. Basically, I'm going to focus on the core services that AWS has to offer, starting EC2, and afterwards we're going to move on to something more advanced like Elastic Beanstalk, and we're going to talk about offering in the file storage that AWS offers, from block storage to object storage, and afterwards we're going to talk about networking in AWS, see how secure it is, and RDS, which is a database offering, and NoSQL offering called DynamoDB. We're going to talk about them a bit. And at the end of the day, I want to show you the abilities of the security abilities that AWS offers. So if you're a small startup that needs to have compliance, or if you're a big enterprise that needs to make sure that everything is secured, AWS can offer you everything you need, and you can use them no matter what your situation is, because if the US government is using them, they're probably safe for everyone else to use them. So let's start by asking, what is AWS exactly? So AWS is a cloud service platform, and they offer services from core services, same as any other cloud providers, like databases, like servers, basic stuff. You can provision any server you need, depending on the requirements you have, or they can also offer advanced services like SaaS things. They have an offering of IoT. They have offering for development tools. If you need a CI server, they also have that integrated. The nice thing with AWS is they offer you the whole ecosystem that you need to build your application, to make sure you focus on building that application, and it's a great company that does great stuff. So, and now we're gonna touch a couple of the stuff they do. So before I begin talking about the core services of AWS, I want to talk about a service that's called CloudFormation. And CloudFormation, to my opinion, is one of the most important services these days, because when you work with cloud, when you work with things today, you need to know that you need your infrastructure to be flexible, which means it's easy to change it, it's easy to update it. It won't take long times if I want to provision more servers, if I want to provision more services other than servers. And CloudFormation is basically a service that allows you to describe your infrastructure, your resources that you need in the cloud as code. So instead of going to the UI and creating everything from scratch, going to all the screens and click on all the buttons and input all the text boxes, in CloudFormation you describe everything in a JSON file or a YAML file, which is a bit more declarative and nice, and it's easier to search afterwards, it's easier to see which resources you have, and You can customize it using parameters, which means I can have a template of creating a web server, and in that template I create a parameter that's called name, and when I upload the file, the YAML or JSON file to CloudFormation, it will ask me, okay, what's the name you want to assign to that web server. So it's customizable. I can create something generic and then from it create a specific object, a specific resource from it. CloudFormation has a nice featured call of drag and drop interface that basically allows me to create my infrastructure as code using a visual editor. So afterwards I just download the file, and I also have the file with me, and it's integration ready, which means it's supported by Amazon and it covers all their services. So if, for example, you want to create a new database, you can do that using CloudFormation template. If you want to create any other servers, any other services from Amazon, everything can be created by CloudFormation. And if you probably heard about Terraform, which is HashiCorp product, CloudFormation is targeted only to Amazon, only to AWS. So if with Terraform you can use different clouds, with CloudFormation it's specific to AWS. And the reason I like it, because it's specific to AWS, it has nice features. You can use functions to do string manipulation and things like that. So it's very versatile, and it's a great product altogether. So I started by talking about that product, CloudFormation, because I think it's one of the core ones that today, in a company that you want to move faster, you need to use infrastructure as code. So even if you have a full meltdown in one region, you can bring up all your infrastructure in a couple of files, upload them, and quickly change DNSs, and or even if you need failover, things like that, you can bring up everything very, very quickly using services like CloudFormation. So it's best practices to use these services and to learn them very well, so you will be able to make sure that you're safe. So after talking about CloudFormation, I'm going to talk about EC2. EC2 is a core service in AWS. It's the service that allows you to have servers, basically. Servers on demand. It has a lot of features inside of it. It has a lot of abilities that it gives you, EC2, and I'm gonna talk about them a bit later. But just to understand, EC2 is servers on demand. It allows you to have auto-scaling groups, which means if based on triggers like traffic, like CPU on the machines, average CPU or memory or things like that, you can auto-scale it to bring up more machines or to downgrade the number of machines you have at the moment. It's completely controlled by Amazon, which means if there is a hardware failure, or if they need to do any maintenance, they'll let you know in advance. And if there is a maintenance need to be done on one of your servers, they will let you know if they need to replace something, if there will be any downtime. Usually they give you enough time in advance so that usually you would want to bring up new servers and close the other ones, so you won't have any problems. It's a reliable service. It's very, very secure, and it's very inexpensive, relatively, of course. It's secure in a way that it integrates with all other Amazon services. So, for example, I can provision new servers, and to that servers I can assign a role in Amazon, and to that role I can set up permissions to access other resources in Amazon. I will show you a bit later into more advanced, but as a general idea, every server has a purpose, and instead of saving keys inside my applications, instead of generating tokens or things like that, I assign a role to that server, and it's an Amazon role. So every time my application would like to authenticate with Amazon to do something, it can use that role and assign to the role is like a user. So it uses that role to do the action based on what that role has permissions to do. So, and of course, each server group can have different roles with different permissions, and the servers can have more than one role and more than one permission, of course. So we're going to talk about it a bit later, and I will show an example of how to assign a role to servers. Right, so moving on, one of the core services in Amazon specifically to EC2 is called EBS. EBS is the block storage for EC2 machines. So EC2 machine can have multiple hard drives, and there are hard drives that are dispensable. So if I drop the machines, the hard drive is gone, all the data on it is gone. And a different type of hard drive is called EBS. So EBS is the block storage, and it's a very high performance volumes. So it allows us to even set up the I/O that we want to that volume. And if we need high volume hard drives, we can set it up to I think 20,000 I/Os, and with optimization it can go up to 40,000 I/Os. So it's highly available. You see 5 nines. You can add encryption on the EBS, which means that AWS will automatically take care of data at rest in these machines, and the data at rest will be encrypted using the key that will be saved in AWS and in another service for them, the KMS. It's a service that keeps encryption keys. So all the encryption keys, all the data will be encrypted at rest, and you can, when you access the data from the EBS, it will be transparent to you. Accessing the data, it's like it's never been encrypted. So EBS can allow us access management, so we can assign volumes to only certain type of machines that has certain role, and we can of course do snapshots, which is backups for the volumes, and from that snapshot we can create new machines. Like if we want to restore data from the past, we can create new machines and attach the snapshot to them, create volumes from that snapshot, and then that volumes attached to the EC2 machines. And they're elastic, so we can increase, decrease the size of them very without actually, shutting down the machines, and everything is very flexible. So every time it's gonna say show me the code, I'm gonna go maybe to the UI or maybe someplace else, and I'm gonna show you basically how to do that. So let's do that. Sorry. So here we're the AWS UI. I'm currently in the London region, which is the closest to me, and this is the EC2 dashboard. As you can see, it has a lot of things, and but from the simplest stuff that we want to do, you can see the sections here on the side. It's divided for 2 instances, images, elastic block storage, which is the EBS. These are the volumes, network and security, load balancing, auto scaling, system manager services, which is basically allows us to manage the servers better. So if we want to run a command, we can do it from here on all the machines. It will basically SSH to those machines and run the command that we want, and other things that we want to do. So I'm going to show you today how to provision a machine in EC2. So, but before I do that, every machine has an AMI. AMI is basically an image that from that image I'm gonna provision that machine. So I already have an AMI ready. As you can see here, we have the AMI ID. So right now all right, let's start over. So in the main dashboard, we can see there is an option of launch instance. It's just a shortcut. I can just easily go to instances, and right now I don't have any instances here, and just click on launch instance. It's what I'm doing right now. It's manual. After that, I will do it with CloudFormation. So you will see how simple it is to do it with CloudFormation. Now, Amazon offers their own AMIs, basic AMIs, for Windows, for Ubuntu, SUSE, Red Hat, whatever distribution you're using. They probably have, the base. But usually you can create your own AMIs. You can use community AMIs, which basically everyone in the internet using Amazon who has created an AMI and made it public. There is a nice interface here showing you, and you can just use that AMI. So right now I just input the AMI ID, and this is a basic AMI with Ubuntu 14.04 and with Apache 2.4, and I just want to show you that after I deploy it, let's select it. Right now I'm choosing the instance type, so depending on the pricing, depending on the requirements you have for your application, of course you choose the right one for you, and you can customize that server instance. It asks us which network should I put it, and how many do I want. So if I choose like 10, it will provision 10 instances instead of one from that AMI that I chose. The IAM role, it's basically that security role that has permissions. So right now I have one here, but I don't want to assign it. I can create new ones. I can create new VPC, which is a private network. I will go over it a bit later in the webinar. So right now I don't want to do anything, but I have a lot of options here. As you can see, I can assign also user data, which is basically a bash script that once the server is provisioned, I can install stuff. I can do whatever I want. So afterwards, it asks me to add storage, and adding a storage can be an EBS instance, or it can be, right, I'm gonna have to do it all over. So I'm gonna do it a bit quicker. So now it asks me if I need any storage, if I want to add new volumes. So I'm just gonna leave it on the defaults, 8 gigabyte general purpose SSD. It shows me the IOPS that I have. I can add tags, so let's add a tag of name, and let's call it my first Apache. So after that, I can configure the security group, which basically means access to that server. So I'm gonna add the HTTP because there is Apache there and I want to access that Apache, so 80. After that, I'm just gonna launch it. It's gonna ask me to choose a key pair. A key pair is basically the SSH key that I will be able to use to that machine. I'm just gonna choose it, tick the box that I do have that private key here, and let's see our instance. So what AWS doing right now is provisioning the instance for me. As we can see, it's in a pending state, and the instance type is a T2 micro, which is a small instance. We have the instance ID, and here below we can refresh it, and then we can see that the instance is running. We can see that we have an IPv4 public IP that AWS assigned to us. we can see the security group, we can see the availability zone that instance was created. We know the region is London, but inside of each region we have availability zones, which is like different building in the same place. So if one building gets disconnected or anything, other buildings might still be working. So it's just for redundancy purposes. We can see the key pair name, that has been used, and basically AWS also gave us a public DNS. So instead of using the IP address, we can use that public DNS to access it. Now, since there is Apache there, I can just call it and see if Apache is loaded. And as we can see, Apache has been loaded, and it is working very nicely. So the server that we provisioned already had Apache inside of it, and we just provisioned that server, and Apache was launched, and we can see it works. So, and using the public DNS that AWS gave us, we can see that. I can use the same way. I can use my public IP and see that I reached the same place, and everything is working. So as you can see. So I want to move back. If you have any questions, just feel free to ask them. Okay, so full screen. Okay. Sorry. We'll just exit the full screen. Yeah. Okay. Okay, moving on to our next service called S3. S3 is AWS file storage, object storage, depending how you define it. It's basically a service that allows us to upload files to it and create folders inside of it, and use it as a storage to everything. It's a storage that you can save files up to petabytes, and it has a lot of nines for durability, which means your files are always safe. They're being replicated to different regions, and you can choose which regions. You can choose how durability you want to have. And it will affect the pricing, of course. So, and it has compliance capabilities, the same, and you can assign roles to access different files or different buckets inside of S3. It's very flexible in terms of management. It's very easy to use, and it can have very fast data transfer abilities. You can use it as a static file hosting. So if you have a static website, you don't need any web servers to deploy that site. You just upload it to S3, tick a couple of boxes, and you can just see your HTML files rendering, your JavaScript, everything. And it has file versioning, so if you're uploading new versions, you can see different files with different versions. You can go back to the past and just redeploy them. So I'm gonna show now the UI of it. Okay. Hi everyone, welcome joining us for the AWS 101. So from the UI, Let's reload it. From the UI, I'm going to go to S3 service. And in S3, currently we do have a couple of buckets, and I've created a bucket it's the same way as a folder, and I've created one beforehand. I'm just going to delete the file that was there before, and let's see, delete. Yeah. Okay, so right now we don't have any files in that bucket. Everything is clean for us to start using, and so from what we can see, it gives us the option to create folders, it gives us the options to upload files. If we go to properties, we see we can enable versioning of files. So if I enable that, every file I upload will create a version. If I will overwrite that file, it will create a version, a new version. We can set up logging from that bucket, so it will log everything we've uploaded. If we change files, it will log everything to CloudWatch, which is the log service in AWS. And we can enable static website hosting. So if we want to have a static website, we can upload it to that bucket and just access it directly in that AWS. So right now it's set up on static website hosting, and we can see the index document is HTML, index HTML. So I'm just going to leave that tick. We can add tags. We can have set up transfer acceleration, which means that files will be transferred quicker, and a lot more options. Here we can set up the permissions, so we can have public access for the log group, different permissions, owner access. We can have a policy for the whole bucket. So if we have a static website, we want to make sure that every time we upload a file, it won't go to the default permission schema. So we want to make sure all the files are public, so at least for read, not to write, of course. So we can set it up in the bucket policy. We can set up cores, so if we get an options or what to do with it, which requests are allowed. And in the management tab, we can set up the life cycle. So if we want to set up as a backup bucket, and we want to tell him, okay, let's save the last 30 days of files. So the life cycle, it's like a cron that does things based on trigger. So it will run every day and check the files when they were created, and if they were created more than 30 days, it will just delete them. We can set up replication to different areas in the world. So if anyone heard, there were a couple of months back an outage in the S3 in Virginia. It's in the US. Now a lot of people got hurt from it, a lot of websites were down, but if they would have just a tick here at the rule to replicate their website to a different region, they would never have been affected. So something to keep in mind. And we can also have analytics, metrics, inventory. So something that everyone should know. It's a great service. So now, just for an example, I'm going to upload the index file that we saw before. And since my static web hosting is already set up, I'm just going to open the file, and I'm going to make sure the permissions are right. So I'm going to grant read permission to everyone to that object because I want it accessed through the internet. So, and I'm going to go to properties, and in here I have the endpoint to that website. So I'm just going to click on it, and as we can see, the index is being served from that bucket in S3, and it says welcome to S3. So very simple, very intuitive, and very, very nice to use service to every file need that you may have. And in today's world, since everything is very, very high traffic. All the systems that we're building needs to have high traffic, and it needs to be very elastic. So we want to make sure that our files are being kept. So working with files in the hard drive, it's nice, it's faster. But if that server is crashing, if we need to add more servers, we need to have a centralized location for these files. So S3 is a very, very good service to rely on and just to work with. Right, so moving from S3 to the next service. Right, our next service is RDS. All right, so RDS service is Amazon offering databases, basically. So, and RDS service it's a managed database service by Amazon. It's very easy to administer that service. It gives us very, very known databases like MySQL, like Postgres, Oracle, MS SQL, which probably using one of them, so it's a good fit for you to use a managed service instead of managing these beasts yourself. It's highly scalable, so if we want to set up replication between servers, usually master slave, we can do that very easily using their interface. We can add up more slaves or reduce the slaves as much as we need. It's highly available and it's durable, so it's using other Amazon services like EBS to make sure that your data is protected. Even if the server crash, the data is kept, and you can have backups, you can do snapshots for that data. You can, from that snapshot, create new databases and go back in time, or if you want to create a staging environment from your production one to run migrations to make sure they're properly working, you can do that with RDS very, very easily, very, very quickly, because you don't need to do all the import and it takes hours. With RDS it can take 10-20 minutes depending on the size of the snapshot. It's a fast and it's secure. You can enable encryption, same as I talked in EC2. The data will be encrypted at rest, and the key will be kept in Amazon in KMS service, so you don't need to worry about anything. It's totally transparent for you, and it's very, very recommended to use encryption to encrypt your data. It's needed today in every field that your company is working. It doesn't matter where, you're probably going to need to encrypt your data, so it's very easy to do it with the RDS. And Amazon as an offering, a specific offering called Aurora. Aurora is a MySQL and Postgres compatible relational database engine, which is an AWS backed up engine that is very, very fast. It has better performance than Postgres, normal Postgres, and normal MySQL. So they recommend everyone to use it, and you can use it even with, I think, the smallest instance type in RDS. So it's very, very highly recommended to use it if you're in AWS, of course. The next service is also a database service. It's AWS NoSQL database called DynamoDB, and it's Amazon offering. It's very fast, very consistent performance. You can set up the performance you want to limit it, or you can have it automatically up and down. So if you have peak in traffic and you want to make sure you have enough connections to the database, and you want to make sure your performance is consistent. No matter how many users you have, just set it up on automatic, and it will automatically set up the connection number and the reads and write and everything. It's highly scalable. Of course, it's managed by AWS, so you don't need to do anything. It's automatically scalable for you. It's fully managed, as I said. It allows you to have event-driven programming, which basically means if a row inside that database changes, it can trigger something in AWS, usually a Lambda function. And I haven't talked about Lambda, but just in a few words, Lambda is a AWS function as a service platform, and it's integrated to all AWS services. So usually if I can do something inside of AWS service, I can trigger from that something, like DynamoDB, one row has changed, and I can trigger a Lambda function to do something. So if, for example, inside of the DynamoDB database, the users table, there was added a new row of a user, so a user was added to the table, and that row triggered a Lambda function that basically said, okay, a user was added, let's send them an email. So that Lambda function can send an email to that user, welcome for joining us, and so on and so on. And as other AWS services, it allows us to have fine-grained access control. So if we want to make sure that our tables are secured and only the persons or the applications or the servers or anything you can think about in AWS, only the specific things we want to have access to that table, to that database, will be able to access it. It's very flexible. It's also a document or a key value data structures, so you can use it to basically everything, whether it's cache, whether it's queues, whatever you can think of. Very recommended if you're using NoSQL. Right, so the next service is another one of the core services that in Amazon, and without this service, basically there is nothing. So if I want to provision a new EC2 machine, I will do it inside of a VPC. VPC stands for a virtual private network, and it's a logically isolated virtual network. So at the beginning, working with AWS, it just gave us IPv4 IPs to the internet, and that's the way we connected to the machines, to one another, to different applications, to databases. And right now, that's not an option in AWS. The only way to work with servers, with machines, with other RDS, whatever you're working with, is inside of a VPC. So before I provision a machine, I need to make sure I have a VPC working, so that I will have where to provision that machine. And it's the same as a router, like Cisco routers and things like that. It creates its own network, and you give it the CIDR, you can set up subnets, and you can do all the routing inside of it. And it's very, very highly, it's not only highly recommended, you have to use it, you don't have any choice. It's very simple, it's very secure, so I can have multiple VPCs in account. So if I have a production environment and a staging environment, I want to make sure they're in different isolated network, so that the staging servers won't be able to access the production one. Like, for example, if I deployed to staging an application that connects to the production database, this is something that is highly not recommended, because it can destroy all the data inside of the production database. So when I make sure that they're in different networks, the staging one won't have access to call the production one, so the application will fail. Of course, it's scalable and it's reliable by AWS, and I'm going to show you now the interface, how it looks. So from S3, we're moving to VPC. So I don't see it here. Let's search for it. Okay, so as I said, inside of the account, I can have multiple VPCs. By default, when I open an account in AWS, Amazon gives me the one VPC per region, so that there is always a VPC there. If I want to provision new servers, if I want to do something, I must have a VPC. So Amazon gives me one by default, and that's the one we can see here. And they just set it up with the IPv4 CIDR, the default one. We can have the ID, and we can see the DHCP options. We can see there's a routing table already created for us. Of course, each VPC has a subnets, so I can have private subnets, I can have public subnets. The difference between them is the private ones might not be connected to the internet, or it can be connected via a NAT gateway, and the public ones can be directed automatically to the internet via internet gateway, or the server will be connected automatically via the IPv4 internet address that he might have. And you can see how many available IPv4 IPs inside that subnet that you may have. And inside of the VPC, I can do anything I want, basically. I can have multiple subnets, and I can have different subnets that won't be able to access the other subnets if I want to make sure it's totally isolated, but I don't want to create new VPC. I can do everything that I want. And as we can see, each subnet has its routing table. It tells him where to go. Right now it's internet gateway, so every IP, it will go through the internet gateway. We can set up ACLs. As you can see, the default one, it's open to all traffic. It's another level of blocking traffic, the ACL. On EC2 machines, you can also have security group, which means which ports are open on that machine, that specific machine. Like I showed you before, I opened the SSH one and the AT one, which is the HTTP one, so I'll be able to access it from anywhere. And so it's a two-way, block for network. We can have the logs and specific tag to each subnet. You can see the routing table. Right now there's only one of them, and that set up the routes to the internet gateway. That's as we showed. It has two subnets that we saw, and we can see we have only one internet gateway. We can set up ingress and egress rules. We can have elastic IPs. Elastic IPs, it's static IPv4 IPs that we can assign to machines, EC2 machine. We can assign it to NAT gateways. We can see endpoints. We can see NAT gateways. We can create a managed NAT gateway by Amazon, so we don't need to manage the machines with the NAT and route traffic. Amazon does that for us. And the last thing about VPC, I know I said that we can create separated private networks, but sometimes I want to be able to connect these private networks, and peering allows me to do that. So I can, for example, I have a production one with a tools VPC that I decided that they are separated, but some tools need to connect to the production ones, or the production servers need to connect to the tools VPC tools applications. So I can peer between the two VPCs and set up the routing, the route table that I want. And after I do that, that servers from production can connect to the tools one, but I can set up rules that the tools one won't be able to connect to that production one. So I can do basically whatever I want. Another something that's very important for mostly enterprise companies is to have VPN connected. So if you have a VPN in your office, if you're a big company, I assume you do have it. And so you can set up that VPN inside your office to the one in Amazon, so that everything is using internal IP addresses instead of external. So that's VPC. It's one of the most important services AWS has to offer, and you have to use it. You don't have any choice. You don't have to use all of its capabilities, of course, but that's why they give you a default one, which is open to the world and assign IPv4 IP addresses and has direct access to the internet. Nothing too fancy. Right, so moving on. Sorry, skipped one. Okay, so our next one is called ELB. ELB is AWS Elastic Load Balancer, which is basically fully managed load balancers by AWS. There are three types of load balancers. Of course, these load balancers allows us to load traffic, whether it's internal traffic inside of that VPC. For example, if I want to have I have a couple of databases and I want to load traffic between them, I can set up a load balancer that does only internal traffic. So it won't have any internet access. It won't have any internet IP address. It will only be internal, so that applications inside that VPC will be able to access each other. So as I said, there are three types of load balancers. The first one is application load balancer. It's I think it's almost the latest. No, the latest is the network one, but application load balancer, it's basically targeted for applications that are connected to the internet that needs HTTP or HTTPS traffic. Today, it's one of the most powerful load balancers in AWS because it allows us to do routing based on subdomains or path that we have. It allows us to assign SSL certificates, multiple SSH certificates, and to that load balancer, so we can have more than one domain on that load balancer, more than one subdomain, things like that. And it's very, very easy to use. It's been used a lot in containers, so it works very seamlessly with another service by AWS that handles containers. It's very, very recommended if you're using containers. The next one is network load balancer. It basically load balancing the TCP traffic, and it has extreme performance, so it's targeting mostly databases or Redis or Memcache or things like that have very, very good performance, that they need these extreme performance capabilities. And the last one is the classic load balancer, which was the first one that AWS offered. It's still good. It does basic load balancing between EC2 machines, and it operates both in request level and connection level, which means we can load balance also HTTP and TCP on that load balancer. But with the two new offerings that AWS are offering these days, it's less and less in use. So I can show you where the load balancers are at. So if we're in the EC2 dashboard, and we can see we have the running instance that we brought up just half an hour ago. We can see it's still running, and we can see here we have the load balancing section, and inside the load balancers, I don't think right now I do have any. Okay, so I don't have any load balancers, but if I want to create one, give it time to load. Okay, so I just click on create load balancer, and we can see the three options. We can see the application load balancer, which is targeted to HTTP and HTTPS. We can see the network one, it's targeted at TCP, and we can see the previous generation, It's both for HTTP and HTTPS. It's still a good service. I'm gonna choose him for now, and I'm just gonna name him my AWS 101, and it's gonna sit inside of that VPC, the default one, and I can just take the the internal load balancer, which basically says that it won't get any internet access, it won't be connected, it will only have an internal access inside that VPC. We can set up advanced configuration if we want, which availability zones, which inside of that region we want that load balancer to be, and things like that. Of course, we still need to open ports to that load balancer, so we'll be able to access that. So afterwards, again, I will just choose which subnet I would like, and then I will choose the security group I would like. So I'm gonna choose both of them, and I can configure health checks to that server. So if basically I have an EC2 machine that is behind the load balancer, the load balancer will do health checks, and if the health check has failed, it won't send traffic to that EC2 machine until it becomes healthy again, and we can set up thresholds and response time and things like that. And now we can add the EC2 machine that we'd like. Of course, we can add more than one, but currently we only have one. Again, we can set up tags, and we can just create that load balancer and go see it has been created, and we can see that basic configuration that we set it up, and we can see the port configuration that we set up. We don't have any stickiness, we don't need that. Here we see the security groups that are attached. We can set up access logs that will save the logs of that load balancer to S3, and we can query the files afterwards, and we can do basically whatever we want with it. We can see the instances that are assigned, we can assign more, we can remove, we can see the health check, we can see the listeners that we set it up. And so right now we can see the status is out of service, the instance registration is still in progress, so which means that the instance is not responding to that health check of that load balancer. It's like it's not reaching it, so we're not going to wait for it. Moving on. Right, I think the last service, no, it's the last service before we're going to talk about more in-depth about security. So before we move on to the security part of things, I want to talk to you about CloudWatch service. And CloudWatch service is AWS offering for logs. So I just had a question if I will touch Route 53. I'm just going to say a couple of words about Route 53 after CloudWatch, but I'm not really going to touch that. It might be, if you would like to, can do a webinar about it in the future, but at the moment I'm not going to touch Route 53. So, as I said, CloudWatch is AWS offering for logs. It basically allows us, it's a managed log service. We can send custom logs to that service. So if we have a service that output logs to files, we can just send it to CloudWatch or to S3, and CloudWatch can take it from there. And it basically allows us to monitor and see the logs of all AWS services. By default, it has logs from EC2 machines that we provision. It can monitor custom metrics. So if I want to monitor specific things that CloudWatch doesn't have by default, I can just add them. It can store the logs. We can set up time when we want it deleted. It can set up alarms. So if it passes the threshold, it will notify us. We can choose the way, email, SMS, whatever. We can see graph and statistics, so we can build dashboards using CloudWatch, and we can react at the end of the day, react to resource changes. So for example, if a resource, which means like if a user was added to the account, and we set up an alarm that says if a user has been added, send it to the admin. So the admin will get an email that a user was added to the account. And it can be anything that you can think of inside of that AWS account. So I'm just going to show CloudWatch how it looks like and what we can do with it. So this is the dashboard, and we can see the health currently. We can browse metrics. So currently we only have metrics from the things that we provision. So we provisioned an EBS, which is the volume. We provisioned an EC2 machine, which is the server. And we can see that we have metrics from both of them. And we provisioned an ELB, the load balancer. And we provisioned an S3 buckets. So let's say I want to go to that EC2 machine and see what kind of metrics I got from it. So we can see we have metric. These are the default ones. We have disk write ops. We can just mark everything and see the graph just filling in. So whether it's network in, out, packets and CPU credits, anything that you can think of, it's here. We can see it in a nice graph, and we can set up alarms based on these metrics, and we can do whatever we want. Here in the logs section, these are the custom logs, so we can send up logs from our application to CloudWatch. It will store them to that period of time that we asked him to, and it will show us the logs from our applications. So it's a good service. It's very, very easy to use, and since you're already in AWS using their services, it makes your life much, much more easier, and it allows you to focus on what's important, which is basically your application and nothing else. All right, so if you have any questions about CloudWatch or anything else, please shoot me a message. All right, so moving on, before I will move on to the security section, I want to talk about IAM. Right, IAM is AWS, how do you call it? I forgot the name. It's access. Basically, it allows me to set up access control and user management, identity and access management. That's the word I was looking for. So IAM service in AWS brings up security as a first-class citizen. So it says basically that if we want to use these services, we need to make sure they're secure. And basically, it doesn't by default make sure everything is open so that you will be able to access it without doing anything. No, they do the opposite. By default, everything is closed in Amazon. You need to set it up so it will be open to your needs. So as you can see in S3, we uploaded the file, and by default it was closed only to the owner. So only the owner was able to read, write, and change that file. So I had to tick a box and change it so that public access will be allowed as a read. So by default, everything in AWS is closed. You need to open what you need. And it's fine-grained access control. So I can set up to the the level I need. So if I have different files in different users and I want user X to access file Y only in read mode, so I can set it up. And if I want another user to be able only to write and read, so we'll be able to read and write, and that's it. And so it's very, very fine-grained to every resource. It's not only files, not only servers, it's also database tables, it's also other services that AWS are offering. And it's connected to everything, the IAM service. Of course, it's managed by AWS. We can use it in our mobile applications. We can do anything we need with the service. It also has a capability of integrating with your corporate directory. So if you have Active Directory, whether it's hosted in Amazon, whether it's SaaS offering by Amazon or Microsoft or whatever, you can integrate it into IAM and set things up from there, and it will be synced. So you don't need to do basically anything. You need to make sure everything is working properly. So let's go into the dashboard of the IAM and see how it's built and what is everything. So the first thing we can see in the dashboard is that that unique URL to our account, and we can customize it. So everyone wants to access that console, this web UI, will go to that URL. We can see the IAM resources we have. We have currently 4 users, 1 group, 0 managed policies, 4 roles, we talked about it before, and 0 identity providers. There is security status, so if, for example, you don't have MFA, which is multi-factor authentication, set up on your root account, it will alert you. It won't be red, it won't be green, and it just couple of steps. Instead of using your root account, create IAM users and make sure they don't have full root access to the account. Of course, use groups to assign permissions so it'd be easier for you instead of going through user by user and setting up that specific permissions. Usually users are setting groups. And of course, you can set up a password policy, so password won't be a valid password. So we can see the groups. Currently, there's only one administrator, and each groups, we can see the names and we can see the permissions to that group specific. And the access advisors show us access to which services we've used, each user, sorry. So we can see the Amazon EC2, Yevgenian, one more user, accessed that service in AWS. So it does audit logging, so we can see who accessed what, with what permission, and we can query everything. I'm sure some of you guys has audit requirements, so AWS takes care for it for you. Of course, you can output everything to files and download it to save it as backups or whatever you want. And you can do it with everything in AWS. You can output every change that a user did and save it inside of a log and then output it and then decide what to do with it. So we can add new users, and we can of course add roles and change the roles. So roles are usually assigned to servers, to services, in 2 resources in AWS. So we give them access to different services or resources in AWS. So and I can also set up roles to have a connection between 2 AWS accounts. So if from one account I would like to access a different one, I can set up role and then I can connect to that role in AWS, in that target account that I would like. So it's, again, the roles are built the same. There are permissions that allow access to something specific. We also have the access advisor. We see the last time that role accessed something. We see it never accessed in the tracking period. We can revoke sessions. We can make sure it's trusted entities and things like that. And of course, we can set up our own policies. These are the ones that are managed by AWS. You can see AWS managed, so we can't change them, we can't edit them, but we can see what it says. So for example, this Amazon Cognito developer authenticate identities, we can see the policy version, we can see which permission it has. It has permission of read to the Cognito identity, read and write, which is limited. So we can add our own policies, or we can use the ones that Amazon is supplying for us, and they're supplying basically all we need. We can add more identity provider, which is other providers that we want to access using them, settings, things like that, everything inside of the IAM. So IAM it's also the same as VPC, one of the most important services in AWS. Without it, you probably won't be able to use AWS at all, because everything is closed by default, and you must have that. You must have that and use it, otherwise it just won't work. Right, so AWS, of course, the services I've gone through, they are the core ones, and other Amazon services are built on these services that I showed you. So, and if, for example, I'm using the RDS service for database, and I provision a service, a database service for me, know that the RDS is just a wrapper for EC2. So RDS basically provisioned an EC2 machine, and it just manages that machine for us automatically. And if we add replicas, if we add slaves, it does the same thing. It creates new EC2 machine and downloads everything, installs the software we need, and just manages for us. So AWS has a lot more to offer in regards of developer tools. So if you're using with you have a CI server, you're using with Git, you want to deploy, which are usually the things that you want to do if you have an application. You want it deployed, you want it tested, you want it log outputting, and aggregate the logs so you can see what's inside your application. So developer tools is very, very advanced in AWS, and they're offering a lot of things. They're also offering a lot of things, a lot of tools in the analytics department. Basically, you can have a managed Elasticsearch service. You have services that are data warehouses like Redshift. You have Athena, which basically allows you to query JSON files inside of S3. So if we saw the S3 service, we can upload JSON files. Athena can query these files using simple SQL, and you can just query and get information from these files. You have managed Hadoop framework inside of AWS, and much more. And of course, many more. Migration services to allows you to onboard very, very quickly. If you have an on-premise database that you want it migrated to the cloud, they have a continuous migration service. So you can do the initial migration using this service, and then continue migrating, creating an online backup in the cloud. They have services targeted to mobile, targeted to applications, so it'd be easier to deploy them. Messaging, they have a service to allows you to send SMSs or emails, and much more. So now we reach the part of the example, and after going through all of the core AWS services, and you can see the power that AWS is bringing to the table, I'm going to talk about Elastic Beanstalk. So Elastic Beanstalk is AWS offering of basically a platform as a service. So it allows us to deploy our application to a managed infrastructure by AWS. So before I talk about it, why I chose the Elastic Beanstalk. Elastic Beanstalk is a service by AWS that allows you to very, very quickly deploy and scale your application. So if you don't know how to do scaling with AWS, if you're new to AWS and you just want to quickly get started with it, Elastic Beanstalk is a very good starting point. It allows your application to be infinitely scalable. So if you have a lot of traffic, it will automatically increase the number of servers that you need. It allows you to deploy to them very automatically and very, very easily. It has a wide range of support to a wide range of languages like Java, .NET, PHP, Ruby, Python, Go, Node.js, and of course Docker. At the end of the day, if your application is wrapped inside of a Docker image, you can just deploy the Docker image and Elastic Beanstalk take care of everything for you in that regard. So if the Docker images crash, it will bring it up again. And so it's a very, very recommended service if you're getting started with AWS, because it shows you all the underlying services that it's using. Basically, Elastic Beanstalk is a wrapper around AWS core services. So we don't need to create a load balancer because Elastic Beanstalk creates a load balancer for us. We don't need to create a container orchestration framework because it uses the one Amazon has. It's just a wrapper that says, all right, create me a new infrastructure for Docker. It provisioned the EC2 machines for us and manage them. If we want to integrate RDS, it can also manage the RDS for us. So it's basically a service that it's a wrapper around the core AWS services. So after we bring up the EC2, the Elastic Beanstalk application, I will go to inside the UI to all these places and I will show you the things that Elastic Beanstalk created for us. So it's a simple example from AWS that I'm going to go through, but I'm going to show you in depth how it looks like in the UI, and afterwards I'm going to show you the structure of how to deploy an application inside of Elastic Beanstalk, which is very, very easy. So I'm just gonna go and show you. Sorry. Okay, so I'm just gonna go in the interface. I'm going to go to Elastic Beanstalk. Okay, so we're in the Elastic Beanstalk interface, and we can see right from the beginning they want us to have it very, very easy. So they just say, okay, you can launch everything from here. So just choose the platform, and I'm going to choose Node.js. I'm going to choose Node.js, and I'm just going to choose launch now. So right now, I'm not touching anything. Elastic Beanstalk is doing everything for me, and it's set up, my first Elastic Beanstalk application, and it calls a default environment. So we can see that the hierarchy of things in Elastic Beanstalk, we have an application, and each application can have multiple environments, and we can, so for example, I can have a production environment, I can have a staging environment, QA, whatever, and everything is very, very flexible. I can bring up new environments, kill the old ones, do whatever I want. So going into the environment, we can see that Elastic Beanstalk inside of the dashboard is going to provision us a Node.js environment. Is going to use a 64 Amazon Linux. We can see the version 4.3 running Node.js. So the 4.3 is not the Node.js version. It's just the Amazon Linux version. So we can see from the events what it's doing. So we can see create environment is starting, and it's gonna create a security group for us automatically. It's creating the load balancer, as we can see, and it's gonna create a security group for that load balancer, and it's gonna say what the environment health is doing, and now it's gonna create a new auto scaling for the EC2 machines. So it will be able to scale up or down the servers based on our needs, which is awesome. This is awesome. So now what Elastic Beanstalk is doing now, you can see it's creating new CloudWatch alarms. So it will trigger alarms whether to increase the number of servers, decrease them. And now I'm going to go to the CloudFormation dashboard. Now, we talked at the beginning what CloudFormation is. So as I said, CloudFormation is infrastructure as code. So as you can see, Elastic Beanstalk, what it did, instead of doing API calls to AWS, telling them create new load balancer, create new auto scaling group, create everything, all it did is brought up a template to CloudFormation service, and we can see the template here. I know it looks bad, but it's JSON. It's just minified. And inside that template, it told the AWS, the CloudFormation service, right, create a new auto-scaling group. Okay, create new ELB, a load balancer, create new RDS, database. Everything is done via CloudFormation. So, and we can see the create has been completed, and now it basically creates the environment for us, which is a lot more than awesome. All right, so going back to the Elastic Beanstalk, we can see it's green, so it's almost done. It's almost done. Environment health transition from pending to OK. Completed 57 seconds and took 2 minutes. So we can see the default environment is up and running, and we can see the health is okay. There are no faults, and it even set up a URL for us to that specific environment. So if we open that URL, we can see that congratulations, the environment has been created and it's already deployed a default application. So since it's starting, hello world, so it's already deployed a default application for us. So as you can see, without doing anything, it created the environment for us. It went to EC2. It provisioned a new server for us. We can see the instances. Inside the instances, we can see 2 machines now. One for the Elastic Beanstalk and one for the one we built. We can see that we have volumes to each machine. So we have 2 volumes. We can see we have load balancer, since Elastic Beanstalk created a new load balancer once it's up. Okay, so we can see the Elastic Beanstalk one, and we can see there is one instance that is in service, so it's answering him. We can see it created a security group for Elastic Beanstalk. Everything was created for us automatically. We can see it even created a new auto-scaling group, which I didn't show before, but it's already created by Elastic Beanstalk. Yeah, everything is done automatically for us. Going back to Elastic Beanstalk, everything is working. So All we have to do now basically is deploy our Node.js application, and it will just work because the environment is already ready. We have the servers ready, and they're just waiting to accept our application. So we can see there is a configuration in Elastic Beanstalk. We can change whatever we want. We can add stuff, we can remove stuff. Right now, for example, the scaling section, it allows auto scaling. We can see the minimum number of instances is 1, the maximum is 4. So if I want to say, okay, I want the minimum to be 3, and right now there's only 1, I click apply, and it will bring up 2 new instances automatically, and it will provision the same version that it's running right now. So as it says in updating, let's go to the EC2 dashboard, and let's see, it brings up 2 new machines. Okay, so what it does basically here, when it says updating default environment configuration, it basically says it's gonna go to the auto-scaling group, because the auto-scaling group is in charge on how many machines we would like to have. So it's going to the auto-scaling group, and it's bringing up the number of the minimum from 1 to 3. That's what I told him to do. So as you can see now, the desired one is 3 because the minimum is 3. So now let's go to the instances section, and let's see, it brings up 2 more machines. Yeah, and we can see it brought up 2 more machines. Altogether we have three machines, and all of them has the same name, which is the default environment, and we can see it here. It's the same name here, default environments. So everything worked as expected. Of course, there are more configurations that we can do. We can change the instance type to make it bigger or smaller. We can have it connect to other AWS resources like RDS. We can set it up. We can change the load balancer configuration, open more ports. We can see the logs here. Right now there are no logs. We can see health status for each instance. Right now we can see that these new instances that we brought up are still undeployed, so it will deploy to them. We can see default dashboards for monitoring. So very, very easy, very, very nice, and very, very recommended, because it gives you a good starting point, and from there the sky's the limit. So right now it's red because now it's green. Okay, because it's done. So if we go to health, we should see the new servers are working, and they're automatically being routed. The requests is automatically being routed between the 3 servers that we've just deployed. Why? Because Elastic Beanstalk deployed a load balancer for us. So it's just working. Right, so but the way we created the Elastic Beanstalk, it's very, very, manual. I just went to the interface. I can just create new application, and this is not the way I want to do it. I want to use CloudFormation. So I have ready from before a CloudFormation template. So, and I will go over it with you right now. So the CloudFormation template that I'm going to show you, it's Hello World for Node.js application. It's basically the same one we deployed. We can see we have an index.html file, which is a static file, and the Node.js, it has basic styling and a couple of links to start with. We can see we have package.json here that does nothing basically, and we have the app.js file, which is the Node.js files that's gonna bring up the server. So we can see it's gonna says latch into port 3000 and require HTTP, require FS, and it's gonna read the index HTML file, and it's gonna save the log of that server into that temp sample app.log, and even if the request is post, it's gonna do something. I'm gonna show you what it's gonna do in a second. So very basic, very simple, and server in Node.js, and we can see there is a login. Okay, we can see here we have a folder called EB extensions. So EB extensions folder for Elastic Beanstalk, it's basically a folder that I can set up things that I want inside the servers. So every time I deploy an application, it will check if in the zip file that I'm uploading there is an EB extension folder. And if there is, it will go through the files that end with config inside of them and will run what it's being told to do. So for example, in this file config, we can see there is a files section, which basically means create that file inside the server, and the content is gonna be this one. So it's basically gonna create two log files, two configuration files, and it's gonna give him the sample app star, which basically tells Elastic Beanstalk add to the Elastic Beanstalk logs the files that start sample app star. We can see it again. Again, it's just with the specific file there. It will add to it. So everything we do inside the EB extensions, it's basically going to be bash, and it will be done automatically on the server for us. So if I want to integrate third-party solutions like install agents or install, if I need ImageMagick or I need tools on the servers, I can have them installed using EB extension files. So every time I deploy, it will be making sure that these requirements are already installed on the servers. But also, if I'm bringing up new servers and deploying a version, so for the first time, it will install all the requirements for me. So it's very powerful, and it allows us, again, to do things as code. So I don't need to remember to install manually something. Everything is done for me. Everything is done for me very automatically. So moving back to the Elastic Beanstalk screen, and right now I'm in CloudFormation. So as I said before, doing things manually will work, but at the end of the day, I want to be more flexible, more faster, and if I have everything as code, if I have templates that allows me to create new resources automatically without me doing anything but uploading a file and input some things. So right now I want to bring up another Elastic Beanstalk stack, and right now I'm going to do it from a file. So I'm going to upload a file. It's called eb.template, and I'm going to click next. Okay, before that, I told you before in CloudFormation you can design your own template. So using the editor, AWS CloudFormation editor, I can create my own environment. So you can see we have lots of resources type, and I can just drag and drop if I want an EC2. For example, let's say I want an EC2 machine. See where it is? Instance. Okay, so I just brought up an instance, and as you can see, it created it for me. Now inside that instance I can have properties. Edit properties. Okay, here are the properties. I can just add them here. So I usually don't work with the designer, but since you're starting up, just to have a good starting point, using the designer is a good option. So I'm gonna upload the file now, the Elastic Beanstalk template that I created. Let's just go over it for a second before I do that. Okay, I'm just gonna open it. Okay, so now I'm just gonna share the screen with you so you will be able to see the template. Okay, so now you can see the template, and let's go over it very, very quickly. So the template is a JSON file that I can set up parameters. As you can see, the key name here, it's basically an EC2 key pair, which is the SSH key to be able to connect to these machines. I can set up description for the template. Mapping allows us, if I want to use that template in multiple regions, so I need to set up specific things for each region. For example, AMIs, which is the images for the EC2 machines, they are unique to regions. So in one region I will have AMI X, but in other region I won't have the same AMI. So in each region I would have to have the image ID. So mapping allows us to do that. So here on the resources section, I will set up resources. So right now we can see I'm going to bring up a web server role, which is an AWS IAM role. This is the type of that resource. And I'm going to give him access to EC2 machines. Again, I'm going to create a new policy. And that policy name is going to be web server role. And I'm going to give him access to these specific roles, as you can see. And another resource I'm going to create, an instance profile, which is also, again, something involves security, because you can see the IAM here, which is IAM is the identity and access management. So everything is related to security. So here we're starting to build the Elastic Beanstalk application. See the type Elastic Beanstalk application, and we just need to create an application, give it a description, and it's ready. But we need to create a new version. So the new version is going to be node.js sample.zip. So this is the zip file that will be used as the version. Every time you upload a new version to Elastic Beanstalk, it needs to be wrapped inside of a zip, all the files inside of it, and then it will be uploaded to S3. And so this is going to build the application for us. After the application, we can see the configuration template, which is the template that Elastic Beanstalk is going to use to create new environments. As I said before, each application can have multiple environments. So each environment should have a template how it will be built. But of course, usually each environment is built using the same template as the other environments. We usually just change the number of servers, because in productions we usually need more servers than in staging. So usually that's the only thing that's different. And at the end of the day, the environment, it's going to be created using that template. You can see template name, it's the same one as here. And at the end of the day, in output, we're going to get the URL of that Elastic Beanstalk environment. So moving to that window of CloudFormation, we're going to upload that same template that I just showed. And now it just asks us the name. So let's call it EB AWS 101. And the key, as you can see, it just gives us a drop down with all the keys that it currently has in the system. There's only one there. Just gonna choose it and move on. Next. Now I'm gonna need to tick a box that says these CloudFormation is gonna create new IAM roles and capabilities, because we need to approve that, because it creates, something that involves security. So we need to approve that. And after we did that, we can see it's going to start creating everything inside of that template. So we can refresh and we can see the number of events. We can see the CloudFormation stack is being initiated by me, and we can see IAM role resource initiated, resource creation initiated, and we can see what's completed. Let's refresh it again. We can see more things are being created for us automatically. There's nothing for us to do. Everything is done automatically for us. Right, let's refresh it again. And let's go to the Elastic Beanstalk interface, and let's see if it's being created for us. So we can see a new application has been created. Now we're waiting to see the environment being created for us again. So now we can see it's creating the roles, the IAM roles, the IAM policy for us automatically. I'm just going to give it time to finish it. At the end of the day, there's nothing for us to do but to make sure it does what we asked him to do inside that template. It's the old one, I'm just closing the tab. So while it works, I want to there is a page that is specific to Elastic Beanstalk. It has all the tutorials and the samples in all the languages that Elastic Beanstalk is offering, or frameworks like Ruby on Rails or Sinatra, .NET, everything that you can think of. They have in their documentation, and there's also a version of Kindle book to every AWS resource, so you can just freely download the book and go over things there. It's very, very easy to get started with. It's very, very quick. You can not only get started very quickly, but you can also deploy to production very, very quickly. Working with one of our clients, I started at the beginning using Elastic Beanstalk. That client has a lot of traffic, and AWS Elastic Beanstalk worked perfectly without glitches. All the deployments went very well, and so I have a very, very good experience with this tool. So now we can see that it's basically what the CloudFormation did was to create a new CloudFormation stack for that Elastic Beanstalk environment, and that Elastic Beanstalk is creating all the auto-scaling and the security groups that it needs, the same way it did before that we did it manually. But now we can see we have the CloudFormation that we brought up created a new CloudFormation stack. So now we can see that the new environment is being created automatically for us. We can see it's adding EC2 instances, created the security group, the auto-scaling group. Everything is done automatically for us. Of course, that template files that I created, they're saved in Git. If you're working in a team, all of the other users can edit them, can push them to Git, making sure they're updated. So you can work as a team on these files, on the infrastructure, and do everything you need. So we can see the Elastic Beanstalk environment has been created. It's just gonna finish uploading, finish creating the rest of the environment in CloudFormation. We can see there is a version being deployed at the moment. The CloudWatch alarms are being configured. Health is set to green. Yeah, we can go into the health. Now we don't see it. Yeah, I didn't enable the, see what it tells me? I should have enabled in that configure that CloudFormation, I should have enabled enhanced health reporting, which I didn't, so we can't see anything here. But here we can see there's no data yet because the application, the server is not up yet. But you can see at the end of the day, in a matter of minutes, automatically a new environment is provisioned to us and it's ready to accept our application, and it's just ready. So again, same as before, it created a unique URL for that environment, and we can see our application being deployed to it. Very, very nice, very, very easy. Recommended to everyone. And we can see here in CloudFormation, it's also create completed, and we're done with that. So I'm gonna share with you the slides. We're gonna send an email with the slides and everything, and a link to the webinar if you haven't joined it, so you can have all the resources that you need. Now, before I finish, the only thing I want to do, which is something that usually happens. So let's say I provisioned an environment in Elastic Beanstalk, and I don't want it anymore. I don't want any of it. It was just for testing purposes, and once the testing is finished, I just want to kill everything. So in Elastic Beanstalk, of course, I can go to the interface and just click actions and delete application, but I really don't want to do that. It will delete everything that I've created, which is what I want, but I don't want to manually go there and do that. So usually, since I'm working with CloudFormation, I can just go here and just delete the stack, and all of the Elastic Beanstalk will be deleted for us automatically. Of course, I'm not going to the interface to do the deletion via the CloudFormation. I'm gonna do an API call to AWS CloudFormation, and then it's gonna delete it. So I want to make sure everything is automatic and working as I expected. And as you can see, everything is being deleted. Also, the environment, the default environment that we created manually, is being deleted for us automatically. We can see here both of them are going to turn red or gray, and they won't be with us anymore. And CloudFormation will delete everything. It will delete the instances, it will delete the auto-scaling groups, it will delete the load balancers. You can see here the instances are being shut down and terminated. You can see the security groups are being deleted. Everything is going to be deleted as if we never deployed anything. See, load balancers are being deleted, everything is being deleted, same way as we created them automatically. So just before we finish, I want to thank everyone for joining us, and make sure you check our website. We have courses for AWS, face-to-face. We have all over Europe. We have ones in London, in Dublin, in Budapest. Make sure you check our website, and I hope to see you on our next webinar. Thank you so much. Have a good day.